Hello, Mr. Peterson here with some more physical science concepts. Today we're going to be talking about force. A force is any push or pull. So if I'm pushing on my desk, pulling something down, or even just walking, those are all examples of forces. Now forces, the label that we use is Newton. The reason is because we give this credit back to Sir Isaac Newton, who kind of discovered the idea of gravity and force in that way. Now the force of 1 Newton is equal to about 1 apple, like a normal sized apple. Now I'm going to let you do some research if you want to know why it would be equal to an apple, but it has something to do with Newton as I discussed earlier. All right. Nextly, if forces are working in opposite directions, which means they're going against each other, we're going to subtract them. And we'll look at some examples a little bit later, but just what I'm talking about here is if I was pulling on a rope against a wall this way, the wall will be pulling against me that way. So I'm going to subtract those two forces because they're going in opposite directions. Now, as you would probably have guessed, if they're going in the same directions, I'm going to add them. So like, let's say if I'm running on a track, I'm running this way, the wind is pushing behind me, I'm going to add those two forces together because they're going to reinforce each other to make things go a little bit faster. All right, as we look at this picture right here, we can see this boy is putting two different forces on a soccer ball. Okay, this one's a little bit bigger, so it has a much bigger arrow to show that it's going this way. This one's a little bit smaller, so it has a much smaller arrow. These are called force diagrams. Now, the one thing I think that they're missing is how much force is actually happening. So this one might be 100 newtons, and this one might be 10 newtons. So I think writing the actual amount of force happening is very important to the force diagrams. If you watch the speed video, you also saw an animation of an airplane doing very similar things. Now the next are unbalanced forces. These are forces that are equal in force but opposite in direction. So forces, the important thing to remember here, forces are still acting on something. So if I'm sitting here, not moving, I still have forces acting on me. I have gravity pulling me down, I have my seat pushing me back up. So even though I'm not moving, I still have forces acting on me. It's very important to remember. They always, this is another very important thing, always have a net force of 0. And what that means is that when I add or subtract all the forces acting on that object, the answer, the sum, is going to be 0 newtons always because there's no movement. Now if we look at this one right here, this picture right here, say this wall is pushing against the car at 100 newtons. So how much would the car have to be pushing against the wall if it said balanced force? You're right, 100 newtons. Because they have to be equal in equal in force but opposite in direction. Since they're pointing opposite ways, we know that there is 0. In this picture of the tug of war, we can notice that the chain really isn't moving. It seems like they're kind of at a stalemate. So maybe these 3 people are pulling with 100 newtons. So each one's pulling with 33 newtons or 33.333 repeating newtons equaling 100 newtons. Or maybe over here this person's pulling with 50 and these 2 people are pulling with 25. So even that on average these 3 people are stronger since this equals 100 newtons and not the average, sorry. But since each one of these is pulling harder than these 2 people, it doesn't matter since the net force or the sum is going to be the same but going in opposite directions. All right, the last type of force that I want to talk about are unbalanced forces. And these are forces that result in the movement of an object. Now there are 3 different ways that an object can move. It can either speed up, it can slow down, or it can change direction or turn. Much like accelerating and velocity can change the 3 different ways that an object is acting, unbalanced forces do that. So in this diagram right here, if I have the wagon moving in this direction, it's because I have a big force pushing this way with 80 newtons and a smaller force pushing this way with only 40 newtons. So the net force here would be 40 newtons this way because I would subtract 80 minus 40, which would give me the 40 newtons going that way since I have the unbalanced forces going different ways. Now, these always have a net force that is greater than 0. Okay, you cannot have a negative net force. It is not possible to push on something harder than not, or softer than not pushing. So if I did end up with a negative 40, what that negative sign is simply telling me that the movement of the object is going to be in the opposite direction. So it doesn't mean that I have a negative force, it just means that it's going in the opposite direction. So if I was to look at these tug of wars, we can see this side over here is pulling harder than this side over here. Maybe they're pulling with 110 newtons, this side's only pulling with 100 newtons. So when we do that, we have that displacement of those people, or the movement of those people, because of the unbalanced forces acting on them. Now, lastly, as I like to add almost every video, I want to show you the website to see where you can go for some more help. So if I go to Chapter 5, Section 3, I can look here what is some net force, some forces tutorial, there's some forces correctives even that I can take, and there's some other review games and things that I can do there.